So this video is going to be going over some of the homework problems that you might have encountered during your homework on Alex. Again, I'm not going to be able to cover every single problem, but I'm going to try my best to cover the ones that I think people would struggle with the most, just so we have some sort of secondary explanation as to how to do them. Alex does a pretty good job of explaining kind of how to tackle certain problems, but again, people think differently and people learn differently, so I figured I'd make my own video on some of these just in case that might help some of you. So the first one's pretty basic. Find the surface area of a triangular prism. So when you have a triangular prism, you always have to do the breakdown method, which is write down each face one by one by one by one by one, and find out the area of each one by one by one by one by one, and then add them back together. Now, as you grow more adept at this, you can start to find shortcuts and stuff to do, but I'm going to kind of do it bare bones here just so that everybody has a good ground level to work out of. So let's start by dissecting this here. So let me take this front triangle first. So this front triangle right here. That's 16 by 12 by 20. Now, I'm not actually going to write down the 20 because even though that's the slanted lines here, I don't actually need that to find the area of my triangle, and that's what my main focus is. So I'm just going to write down the information that I need and nothing else. So 16 by 12, put a little right angle there, put a little F here so I know it's the front. And the back triangle is the exact same, right? So the back triangle is also 16 by 12. So 16 by 12. Again, back triangle is this one back here. It's also 16 going the same direction by 12 going the same direction. So to get the area, I'm going to do 16 times 12 divided by 2. That's the area formula for a triangle. So 16 times 12 divided by 2, we get 96. And then that would also be the area over here, right? Because again, it's the same exact triangle. So front and back are taken care of. Now let's go ahead and see if we can't work out the bottom. So bottom rectangle rather is 12 by 18. So draw that here. I'll put BOT for bottom. We'll do 12 by 18. Obviously it's not drawn to scale, but that's fine. And the way you get the area of a rectangle is you do 18 times 12, base times height. And we end up getting 18 times 12. We get 216. So that's the area of the bottom rectangle, this one right here. Now let's see if I can't get the area of the slanted rectangle here. So this one is kind of on the right side. So I'll put R here for right side. This is my right side rectangle, and it looks to be about 18 by 20. So 18 by 20. Technically, it doesn't matter where you put your numbers on your rectangle because base times height is base times height, no matter which one's the base or the height. So I'm just going to try to make them as appropriate as possible. So 18 times 20, base times height. That would give us 18 times 20 would be 360. Remember, no cutting in half for a rectangle. It's only for the triangles. And then lastly, we have the left side rectangle. So that's this one back here. Boom, 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 boom. Again, there's always 5 shapes to a triangular prism. 2 triangles and 3 rectangles. And this one is 16 by 18. Because again, this line here, right there, that line goes the same direction this line does. So they're both going to be the same, which is 18. So this is 16 by 18. And this is my left. So that would end up being 16 times 18, which gives us a grand total of 16 times 18, 288. And so then to the finale here, we're going to add all these together here. So 96 plus 96, those are my 2 triangles, plus 216, plus 360, plus 288. And let's see what that gets us here. So 96 plus 96 plus 216 plus 360 plus 288 would give us 1056. And that would be in square feet because it is an area question. So that would be my answer, 1,056 square feet. Again, you always have the same sort of style of breakdown for triangular prisms. The numbers will be different and the picture might be different, but it's always the same style. 2 triangles, three rectangles, and the rectangles should always have a common number between them all. So in this case, my common number was 18. So this rectangle had an 18, this rectangle had an 18, and this rectangle had an 18. So they're always going to have one common number between all rectangles, at least one common number between all rectangles. So you can kind of use that to make sure that you're getting your numbers placed right to kind of use that rule as a guide. The next one is a rectangular prism, or a box as most of you call it. Now we could do this one the same way by breaking it down rectangle by rectangle by rectangle, but I told you that rectangular prisms actually have a shortcut. Now it's unfortunate that these are 5, so actually let me make a minor adjustment here. Let me change this to, instead of being 5, to be 6, just so it makes this next part a little bit easier to look at. So I'm going to change this from 5 to 6. I told you that for a rectangle there's a special trick you can do. This is what we would call a 6 by 8 by 5 rectangular prism. We're just going to put the numbers in a row here, just like we'd say a 2 by 4 rectangle, 6 by 8 by 5 rectangular prism, because it has 3 dimensions, so you have 3 numbers. The way you can do the surface area is you do both numbers paired with each other once each. So 6 and 5, pair those together. 6 times 5, that's one of your rectangles. Then 6 and 8, pair those together. 6 times 8, that's another pair of rectangles. And then 8 and 5, pair those together. So 8 times 5, that's your next pair of rectangles. And again, the reason I'm doing this is because if you look here, here is my 8 by 5 rectangle. That's an 8 by 5 right there. Here is a 6 by 5 rectangle. That's a 6 by 5. And then in the front here is a 8 by 6. That's an 8 by 6 rectangle there. So I'm just hitting all 3 styles of rectangles here. Now, as we said before in the previous video about prisms, that in a rectangular prism, every rectangle has an opposite. So if I have a 8 by 5 on bottom, that means I have an 8 by 5 on top. If I have a 6 by 8 or 6 by 5 on the left, that means I have a 6 by 5 on the right. And if I have a 6 by 8 in the front, that means I have a 6 by 8 in the back. So every one of these rectangles has a double. So instead of, again, writing them all out, I can just do this. Times 2, times 2, times 2. And then just find out all these and then add them together at the end. So 6 times 5 times 2, well, that's 10 times 6, that'd be 60. Get that there. Let me make that 60 better, just because it's annoying me. So 60, there we go. Here, 5 times 2 is 10, times 8 is 80. And then here, 6 times 8 is 48. 48 times 2 is, just so I don't have to do this twice, 96. And then you add all these together, which I'm going to do to make sure, once again, I don't have to make this twice. 80 plus 60, 236. So 236 square inches would be your answer. You could also, by the way, you could just do this, find those out, add those answers together, and then times it by 2 at the end. So whether you times 2 here or at the very end, it doesn't really matter as long as you times 2 at one point, because again, the whole reason that this shortcut works is because you're basically doing each rectangle once, and then instead of doing it again separately, you're just doubling your answer. So instead of doing 2 6 by 5s, you're just doing 6 by 5 once and then doubling it. And again, what this results in is basically you pairing each number up once. 6 and 5, done. 6 and 8, done. 8 and 5, done. And then just double, add, and get your answer. That's it. So again, if you remember that process, you have that shortcut for rectangular prisms only. Notice that does not work on these because these do not have copyable rectangles. Each rectangle here is different. They share a number, but the end result was always a different area. So we can't use that shortcut for triangular prisms or any other style of prisms for that matter, but we can use them for rectangular prisms just because they have that property of having a double for each rectangle. So for cylinders, cylinders had a formula you need to know in order to get its surface area, and that was the following formula. 2 pi r squared plus 2 pi r h. Actually, the way we said it was 2 pi r h plus 2 pi r squared. These are both the same though, so no matter which one you do, as long as you have both categories in there, 2 pi r squared and 2 pi r h, and then added together, it doesn't matter which one you do first technically. But this was the one that we kind of talked about in the video there, the second one here. So that's the one I'm going to use. So let's write this down here. So my 9 is my h. Your height is always the line that connects your two circles. So if you look at a cylinder, find one circle, find the other circle, whatever line connects the two, that's your height. So 2 pi. Now my r, remember, my r is the radius of my circle. So this is 4 meters. That's the diameter. That goes all the way across. Diameter of 4 meters. I just want the radius, which is just halfway across. So if the entire thing is 4, that means my radius has to be 2. Again, always be on the lookout for that. Very common trick to pull. So 2 times 9 plus 2 pi, and again, r squared. So not 4, but 2 squared. Now it says write your answer in terms of pi. So if you hear that phrase, write in terms of pi, that means they don't want you to multiply the pi in. Treat pi like an x, essentially, is what it's saying there. In terms of pi means treat pi like an x. So you wouldn't multiply the x in there, you just keep it at the end of the number, right? So here I'm going to do 2 times 2, which is 4, and then 4 times 9, which is 36. So 36 pi plus, let's see here, 2 squared. 2 squared is 4, and 4 times 2 is 8 pi. And then add these together, 36 plus 8. Again, think about it as an x. 36x plus 8x would be 44x, but in this case, instead of you saying x, we're just going to say pi. So 44 pi meters squared. So this is how you would write your answer. And when it says in terms of pi, you wouldn't write out what that decimal is. Now, a student emailed me a while back and said that they did it this way. They actually did it by multiplying the pi in there. So they did 2 times pi times 2 times 9. And then they added that to this part here, 2 times pi times 4, which is what 2 squared is. And then if they said that it was in terms of pi, all they did was they took their answer and divided the pi back out. So divide by pi, and then you get back to your 44. So then they would write it as 44 pi because then they knew that that was the number that went with the pi. So if you don't like keeping the pi in there, you can actually multiply it out and get your decimal. But once you get your decimal, before you even round, because you can't do this if you rounded, because your calculator will not give you the exact answer if you try to round first and then divide out the pi. You have to get the exact number, which is using this big long decimal here. But if it says write your answer in terms of pi and you accidentally get the decimal, just divide it by pi and you'll get whatever the coefficient is supposed to be out of it. So that's another little creative way you could do it too. Next one here also deals with the cylinder. Now this is a special kind of problem here because it gives you the dimensions. It says that this is a can of soup, 8 centimeters wide by 7 centimeters high. And it says that we're making a paper label that is going to be wrapped around the can that only covers the side. So again, not the top or the bottom. If the company makes 14 labels, how many square centimeters of paper will be needed? And it says use 3.14 for pi. Do not round your answer. So that means we don't want to, as it says here, round our answer. So we're going to do our best not to. And we're going to use 3.14 instead of pi. So when it says this, that means it wants you, you have to write in 3.14 in your calculator, not the pi button, because if you type in the pi button, you'll have to round. And again, it says do not round. So just make sure you follow the minor detailed instructions here. But the way we do this one is we notice here that it says only the side of the can. So normally the way we get our surface area is we do 2 pi RH plus 2 pi r squared, right? This will give me the total surface area. This will give me the surface area of everything, top, bottom, and the side tube. But I don't want the top and the bottom. So this is where you have to kind of memorize, or not memorize, but know what the formula means here. This part here is for the top and bottom. That gets the area of the top circle and the bottom circle. This part here is for the tube. That gives you the area of this curved tube section there. So if I only want the tube part and not the top or the bottom, that means when I do this, all I'm going to do is the pi RH portion. I'm not going to do the 2 pi r squared portion because it doesn't want the top and the bottom, it just wants the side. And again, this is what gets you that curved tube section. So when I do this, I'm going to write in 2 pi, and I'm not going to write in 8 because remember 8 is the entire thing across. I just want the radius. So that's going to be 4 that I use. Again, half your diameter is your radius. So 2 pi 4 times 7. Now it says use 3.14 for pi, so that's what we're going to do. 2 times 3.14 times 4 times 7. And we get 175.84. Do not round, so we're going to write it as 175.84. 175.84 square centimeters. Now, this is for one can, right? Because again, it says that this is the dimensions of one can. We want to make 14 labels. So we want it for 14 cans. So once again, we are going to take our 175.84 times our 14, and that should give us how much for 14 cans. So 2,461.76. So 2,461.76 square centimeters. And it says do not round, so we would leave it as this. We leave the 0.76 on there because their instructions are to not round, so we're not going to do that. So when you have word problems, always make sure you're actually answering the question, because once again, they'll throw that little extra bit at the end where you have to multiply by 14 or multiply by 5 or something, because they want it for 6 or 7 or 8 cans rather than just one. So make sure you read the questions carefully so you know whether you're using the top, the bottom, the side, or everything. If they just said they want everything, they want to label every part of the can, top, bottom, and side, then I would use the entire formula. If they just wanted to put their labels on the top and the bottom, then I would just use this part. But if they want to put their label on the tube portion or the side of a cylinder, that's where I use the first part. So 2 pi r h, that's for the side. 2 pi r squared, that's for the top and the bottom. So either use them both if you need both, or just use the portion you need if you don't need to use them both together. And that comes from making sure you read the problem carefully and making sure you assess the situation. And again, always be on the lookout for those extra little bits at the end that require you to multiply one more time. And the last one here, we have this sort of composite 3D figure. So it's made up of a rectangular prism, like down there, and then a half cylinder on top. It says that this is the outline for a mailbox. It's made of aluminum. They're going to make 1,933 mailboxes. And it says each mailbox has these dimensions. How many square meters of aluminum will be needed to make these mailboxes? And it says use 3.14. Round up your answer to the nearest square meter. Okay, so lots going on here. So let's break it down. We need to get the surface area of this mailbox, because again, that's how much aluminum we're going to need. So picture out this is like a blank diagram. We want to cover each piece with aluminum because we want to build an aluminum mailbox. So that means I want to start by looking at the rectangular prism part because that's going to be the easiest one to do. So let me break it down face by face by face by face. I could do my little doubling trick here, but because it doesn't have a top piece, this box doesn't have a top section, that might be a little confusing for some of you. So I'm just going to do it piece by piece here. So I want first this rectangle right here, and that looks to be 0.5 meters by 0.6 meters. So 0.5 times 0.6, that's my front part. And then I have it over here as well, 0.5 times 0.6, which is on the back. So 0.5 times 0.6. And yes, I could do times 2 here, but I'm just doing it piece by piece just to show. And then let's try to do the front and the back rectangles here. So this front rectangle needs to be aluminum. So that's a 0.75 by 0.6. So 0.75 by 0.6. And the back side, here to here, is also 0.75 by 0.6, right? So 0.75 by 0.6. And then I don't need, whoops, I hate when I do that. Always annoying. There we go. I don't need a top section. I don't need this top rectangle here. This top rectangle doesn't exist because again it's covered by the half cylinder. But I do, if I erase that there, I do need this bottom rectangle, this one right here. That bottom rectangle I do need because that is part of the mailbox. That's going to be 0.75 by 0.5. So 0.75 by 0.5. And let's go ahead and figure out what these are here, just so that we don't lose them. So 0.5 times 0.6 is going to be 0.3. So 0.3, 0.3, and then 0.75 times 0.6. So 0.75 times 0.6 is 0.45. So 0.45, 0.45, and then we have the bottom piece, which is 0.75 times 0.5, 0.375. So that gets me all the sides of the rectangular prism. Now, I need to get this curved piece on top, this half cylinder. Let me see if I can outline it best I can here. So I need to get this half cylinder piece on top here. So then I have a curve this way, and a curve that way, and a line going that way. So I need to get this top half cylinder looking piece here to get my answer. Now, in order to get the half cylinder, I need to figure out its radius, right? And it doesn't tell me what the radius is automatically. Let me erase part of it here. It doesn't tell me what the radius of this is automatically, but it does tell me that this right here is 0.5, which means that this right here is also 0.5, that line right there. And if you notice, that's the diameter of this little half circle, right? This little half circle has a diameter of 0.5, which means if I want just the radius, I can just cut that in half. So 0.5, try it again, 0.5 divided by 2. If we do that real quick, 0.5, 0.5 divided by 2 gives us 0.25. So that is my R. That's the radius of my half cylinder. Now, I also need the height of this half cylinder, because without the height, I don't have my 2 pi RH. So the height, remember, of a cylinder is the line that connects the two circles, or in this case, the two half circles. So there's my half circle at the end, and here's my half circle at the front. And I'm looking for the line that connects these two half circles. Whoa. I'm looking for the line that connects these two half circles. Well, that would be this line right here, or this line, or the dotted line across from it. But this line right here we know, because if it's this line right here, we know that, okay, well, this one right here is 0.75. So that means that this top line right here also has to be 0.75. So that means 0.75 is my height, because that's the line that connects the two half circles. So what I'm going to do is I'm going to do my formula here. 2 pi RH plus 2 pi R squared. Now in this case I'm going to do the entire formula because I want the entire thing covered in aluminum, not just the side, not just the top and the bottom, but I want the entire half cylinder covered. And because it's a half cylinder, I'm going to do this and then I'm going to divide it by 2 because I only want half the cylinder, not the full cylinder, because again it's only a half cylinder on top. So this would be 2 pi times 0.25 times 0.75 plus 2 pi times 0.25 squared. Remember, 0.25 squared is not 0.5. It's asking for 0.25 times 0.25, not plus itself. So let's go ahead and figure this out. It says use 3.14 for pi, so that's what I'm going to make sure I do. So times 3.14 times 0.25 times 0.75, 0.75. That gets me that, plus parentheses 2 times 3.14 times whatever 0.25 squared is. And we get that all divided by 2. And we get 0.785. So 0.785. And lastly, or not lastly, but nextly, I'm going to add all this good stuff together. So add all my areas together. So add. So everything here gets one big plus. And so let's go ahead and do that. So 0.3 plus 0.3 plus 0.45 plus 0.45 plus 0.375 plus finally 0.785. Actually 2.66. So I get 2.66 meters squared of aluminum that I need to make one mailbox. Now again, I also told you in word problems, make sure you're on the lookout for those extra little tricks at the end, because it says it's going to make 1,933 mailboxes. It wants to know how much aluminum it's going to need for the entire operation, because it says for these mailboxes, it's plural there. So for the entire operation here, for all 1,933 mailboxes, how much aluminum would I need? So that's what we do. 1,933 times 2.66. So let's go ahead and figure out what this is. Times 1933. We get 5141.78. So 5141.78. And it says round to the, round to the next square meter. So that means the nearest square meter. So that means I want to round this up to the nearest whole number, essentially, which means that this 7 would round the 1 up to a 2. So it'd be 5142 meters squared. That would be my final answer. So once again, if you have a composite figure, your goal is to break it down into uh, the individual faces, or if you can, the individual shapes, but you have to remember that if it's a composite figure, especially with surface area, sometimes if you break it down into individual shapes, not every part of the shape is used. Like if I broke this down into a prism and a half cylinder, the top part of this rectangular prism was not used because it was covered by the half cylinder. So when you have a composite figure, I always suggest that you actually break it down into face by face by face rather than just into different composite shapes, just so that you don't double count yourself when you need to. And again, don't be afraid to divide by 2 if you have half a shape. If you have half a cylinder or half a cone, divide it by 2 like you would for a regular cone. So do the regular cone operation, divide it by 2. Do the regular cylinder operation, divide it by 2. So don't be afraid of doing half stuff there when it pops up and is appropriate. That's it for this one. Again, if there was a question on your homework you didn't quite understand and I didn't pick out for this video, please let me know and I can help you out. Please make sure you remember to actually do your homework and your RPS and stuff on Alex and get that in. And please make sure you write down your written work on a piece of paper for your highest scoring RPS and upload that to Google Classroom. Because again, if you do make like a rounding error here and you put 5141, the system will count you off completely. I won't. But I need to see that in order to actually give you credit for that, or in order for you to earn credit for that. So please make sure you write down your written work. That way, if there's like a labeling mistake or a rounding error or something like that, something silly, you can still earn most of your partial credit through that way. But again, I need to see that on Google Classroom in order for you to have that assurance. If not, I'm just going to take what the system gives you because I'm not going to try to backtrack from just an answer about what you did there. So if you have any questions, let me know. Hopefully this video helped you out. As always, have a good day or good night or good afternoon whenever you're deciding to watch this video. And I hope to see you soon, if at all.